All right. Welcome back for the February test of the Math Open. Question number 1. We have 40 kids who take this test each month. If half of them study for 2 hours and the other half study for 6 hours, how many total hours of studying is done by all 40 of the students? So we start with 40 kids and half of them study for 2 hours. So we know half of 40 is 20. So 20 times 2 is 40 hours total. The other half is 20 times 6 is 120 hours total. And you can add that up and you can get 160. And that's your answer. Good job. Question number 2. A kid needs 1,300 milligrams of calcium a day. A glass has 300 milligrams of calcium. How many glasses of milk would you need to drink in a year to get all your calcium? So we start knowing that you need 1,300 milligrams of calcium each day. And then we can figure out how many milligrams of calcium you need in a year by taking that 1,300 times 365, and that equals 474,500. And then we can figure out how many glasses you need in a year, which is what the question's asking. And then that's just division. In a year, you need 474,500 milligrams of calcium, and each glass has 300 milligrams, so 1 divided by the other gives you 1,582. And there's your answer. Good job, everyone. I've always wondered why I can't fly, so maybe here's the answer. If an eagle weighs about 6 pounds and each wing is about 3 feet long, how big would my wings have to be if I weigh 150 pounds? So we know that an eagle has a 3-foot wing and weighs 6 pounds. And so you can break that down to say for every 2 pounds the eagle weighs, he needs a wing that's 1 foot long. Every 2 pounds equals 1 foot of wing. Well, I'm 150 pounds. So for every 2 pounds I need a 1 foot wing. That means 150 pounds divided by 2 means I need a 75-foot wing. That's each wing. So if I needed to fly like an eagle, I would need to have 2 75-foot wings. That's really big. That'd be difficult to get into like a building, like a school or something like that. Question number 4. I have $2,000 and I can invest it at 8%. How much would I have after 9 years? So here's the compound interest problem we always know we're going to have. We have our equation. What you start with times 1 plus your interest rate raised to the number of years equals what you end with. And let's figure out what variables we have. We know we're starting with $2,000. We know we have an interest rate of 8%. We know we're going to do it for 9 years. And we know it's going to end, or we don't know what we're going to have when we end. That's the question. So let's put all those numbers into our equation. 2,000 times 1 plus 0.08 raised to the 9 equals. And you can just figure that out. The first thing you do is you figure out what 1.08 raised to the 9 equals. That's 1.99. So 2,000 times 1.99 equals $3,998. Good job, everyone. Question number 5. If a room had 1,000 kids and all of them flipped a coin 6 times, how many of those kids would you expect to get all heads? So this is a good probability question. So we're starting with 1,000 kids. Now after the first flip, we would expect 1,000 kids to go down to 500 kids because the chances of getting ahead is 50%. So you take 1,000 times 50%, and that gives you 500. And then after the next flip, you take that 500 kids, you multiply that by 50% again, and you get 250. So now after 2 flips, instead of starting with 1,000 kids, you now have 250 kids who've flipped heads twice in a row. After 3 flips, it goes down to 125. After 4 flips, it goes down to 63, 31, and 15. And 15 is your answer, but I hope you notice something. Notice what we did every time. It probably started to get a little boring after a while. Every time we were multiplying the number by 50% or 0.5. Well, we should know by now that there's actually a really important button that you can use when you want to multiply a number by itself many times. You can take 1,000, which is the number of kids we started with, and you can multiply that by 0.5, the 50%, raised to the 6th power. Raising it to the sixth power means you multiply the 0.5 by itself 6 times. And you'll notice in what we did on the left, that's exactly what we did. We took 1,000 times 50%, took that answer times 50%, took that answer times 50%. We did that 6 times. Mathematically, that's the same thing as taking 1,000 and multiplying it by 0.5 raised to the sixth power. Either way, you get 15 kids. And good job if you got that one right. That was not an easy question. And here's our last one. This is a bit harder. What interest rate would you need if you wanted to invest $1,000 and have $1,150 after 2 years? So this is the equation we're all used to seeing. Now let's figure out what we know. We know we're starting with $1,000. Now the interest rate, normally we have that, but this time we don't. So that's what we're going to need to figure out. We know we can do it for 2 years, and we know we're going to end at $1,150. So this is what the equation looks like, and we want to get the r by itself. So the first thing we're going to do is we're going to divide both sides by 1,000. When we divide both sides by 1,000, we have 1 plus r raised to the second power equals 1.150. Hopefully that's pretty easy algebra. Now this is where it gets a little tricky. The next thing we want to do is we want to get rid of that 2. How do we get rid of that 2? Well, we can get rid of the 2 by raising both sides to the 1/2. When you do that, the 1/2 and the 2 cancel each other out. And so what you'll have is you'll have 1 plus r raised to the 2 raised to the 1/2. Those cancel each other out, equals 1.15 raised to the 1/2. And you know how to do that on your calculator. If you take 1.15 raised to the 1/2 or 1.15 raised to the 0.5, same thing, you get 1 plus r equals 1.0723. Then you just subtract 1 from both sides and you get r equals 0.0723 or 7.2%, and that's your answer. Good job, everybody. This is the third and last flavor of these compound interest problems we'll do, where now we know how to solve it if we don't know what we start with, if we don't know what the interest rate is, and if we don't know what we end with. As you get a little more advanced in math, you can do it where if you don't know what the number of years are, but that involves logarithms, so we're going to wait on that a little bit. Congratulations, everybody, on doing the tests. Like I always say, these tests are hard. Just that last compound interest problem is probably a good 9th or 10th grade problem when you learn that. So if you're taking these tests, these are no joke, and you're doing a great job. The next test will be March 18th, so I look forward to seeing everybody then.